Hello, my name is Pearl Victoria Husiame. I'm a senior meteorologist here in Gaborone Department of Meteorological Services. Today we'll be looking at the Botswana DDMC data capturing tool for metrology. So we're going to look at the videos are going to cover the setup of the Excel data capturing tool. So we have an Excel file. It's going to the one that we've been using for the longest. So we've done a few improvements on it. We've shortened it. We've added a few calculations here and there, but mostly it's the same things that we've been doing throughout the years. So we have long-term data on the first sheets. We have monthly data that has rainfall from July, August, September, all the way up until June for each and every year. So these will be in sheet 2 to 13, and then 14 and 15 are the seasonal and the comparison sheets. And we have a hidden sheet number 16. It's where we calculate the onsets and the cessation of rainfall. We're also going to look at the standardized precipitation index because it's one of the drought indices that we want to be able to capture and look at, apart from just the departure from normal, because we've been looking at that for the longest. And we're also going to look at the reporting that when you do write the report for drought assessment, what do you look at, what should you input, and all that. So for now, let's look at the standardized precipitation index. The standardized precipitation index, as it says, it's an index that talks to precipitation. There are other weather parameters that you can look at, like such as soil moisture, temperatures, and others. But unfortunately, I'd say data-wise, we all know our problems with data. So the SPI is widely used internationally and is pretty easy to use and pretty simple to calculate. So we've included that as an addition to the departure from normal. We've been using the departure from normal for a very long time. So the SPI is widely used tool for categorizing drought and wet conditions based on precipitation data. It quantifies how much the observed precipitation deviates from the long-term average, just like the departure from normal. The only difference is that it does a normalization such that the SPI can be used worldwide. The SPI formula is the precipitation for this year. If we're in 2025 and we're looking at January, February, March to see whether the second half of the rainfall season, did we have a drought or not, we'd look at the average rainfall for that for those 3 months, and then we'd subtract the long-term average rainfall for those 3 months as well as the standard deviation. We've been able to calculate the standard deviation for all the stations. I know for a lot of stations the long-term average rainfall has been calculated and it's been there for quite a while. So the standard deviation was the only data that we needed to capture for each and every station, and we've done that. Now, the key for SPI is that if your SPI is between 0.99 and minus 0.99, you classify that year as a normal year. But if it's between 1 and 1.49, you classified it as a moderately wet year. But if it's in the negative, minus 1 to minus 1.99, you classify that as a moderately dry year. If it's in the severe drought, you're talking minus 1.5 to minus 1.99. And anything greater than minus 2 would be an extreme drought. So the opposite is true for wet years. Now, the information I'm about to present comes from the WMO Standardized Precipitation Index User Guide. That is WMO number 1090 of 2012. It says that drought is an insidious natural hazard. So it's very important for us to recognize that drought is natural. And Botswana and Southern Africa, drought is very natural and it occurs quite a lot for our area. and it's a result of lower levels of precipitation than what is considered to be normal. It's a regional thing. Like I said, it covers, if we're having drought in Botswana, obviously other Southern African countries are going to be having drought as well, and has specific climatic conditions. That is, the rainfall will be lower than we consider to be normal. Droughts are commonly classified by type. We have meteorological droughts, agricultural, hydrological, socioeconomic droughts. But the one that we are focusing on are the meteorological droughts. And the SPI is an indicator to help us consider what type of meteorological drought are we having. Is it extreme? Is it severe? Or are we having a normal year? So the other thing to consider is that droughts from year to year differ in terms of intensity, differ in terms of duration, and spatial coverage. Some droughts can go for like 5 years, 4 years, 3 years. Some is just a short space of time, like 3 months, 6 months, and other years you can have like prolonged years where we have like wet conditions. Over the years, many drought indices were developed and used by meteorologists and climatologists around the world, such as the percentage of normal precipitation. This is what we call the departure from normal, and we have been using it. And all we're doing now is just adding to this one. We will be looking at the percentage departure from normal as well as the SPI. The other drought indices, such as the precipitation percentile, we don't really use this one a lot, and the more complicated ones, such as the Palmer Drought Severity Index, we haven't really used this one. So this is the percentage of normal precipitation, or the departure from normal, is one index that we've been using, and then in addition to that, we'll be looking at the SPI. So American scientists McKee, Doskin, and Klixt developed the SPI in 1993. You should be having data of 30 years. We all know that WMO states 30 years or more. Ideally, if you have like 50 or to 60 years, that would be optimal. But we know our problem of data, so 30 years is fine. Just like we've calculated the mean for 30 years and the standardized and the standard deviation for 30 years. It's easy to calculate. The SPI is easy to calculate. The precipitation is the only input. It can be computed for different time scale, that is 3 months, 6 months, a whole year, 24 months, and all that. But most of the times we'll be concentrating on the 3 months and the 6 month SPI. It's also a tool when it comes to providing warning of drought and help assess drought severity for early warning purposes. For the next video, we'll be doing an example of how to calculate the SPI.